Welcome back. So today we're focusing on the VLANs, right? So we want to go through, I want to break it down first. What a VLAN? When are we going to need to use the VLAN? What's the main use of the virtual local area network? So we've covered the local area network, what it means, what is a local area network. We say the local area network, it is found in one geographical location. So like your building, the building of your school or maybe an organization, that's a local area network that you have there, right, in one building. So a local area network is found in one geographical location. So that's what we call a local area network. But now we bring in the VLANs, right, the virtual local area network, whereby we are logically separating that LAN that we have created. We want to break it down into different groups. And then what would be the reason for us to break down a local area network? So we just want to go through that process of breaking down the local area network and then explain also why we do want to create a VLAN in our network, right? So let's dive deep into it without wasting any time. Let's just dive into this training. Let me see. So my next slide, here's my next slide, right? Intro to VLAN. So what is that? So VLAN is a logical grouping of devices in the same broadcast domain. So what we mean by broadcast domain, we said if devices are all in one local area network and then they are all at the same subnet, that part we call it a broadcast domain. So if one device broadcasts a message, all of the devices in that subnet are going to receive that packet. They're going to hear the message, right, that is being broadcasted to all of them. So that's why we call it a broadcast domain. They're in the same subnet and the same network, right? So the device that broadcasts a message, all of the devices that are part of that network are going to receive that message, right? And then VLANs are usually configured on switches by placing some interfaces into one broadcast domain and some interfaces into another. So by default, a switch is under what we call the VLAN 1, right? So by default, all of the devices that we have in our network, they're in the same VLAN. Unless we configure virtual local area network, or unless we configure a VLAN, that's when we can logically separate those devices using the ports. Maybe you say maybe port number 1 is under VLAN 10, port number 10 is under VLAN 10, and then port number 20 is under VLAN 20, and other ports are in VLAN 20, and then other on VLAN 10. So you are logically separating the ports, even though they are in the same switch, but they might be on the different VLANs. So that means if they are on a different VLAN, then the noise will be contained in one broadcast domain. So if if one switch that is on VLAN 10 broadcasts a message, then that message will be contained in that VLAN, even though they are all directly connected to one switch. So that's the VLANs. That's the main use of a VLAN, to kind of like reduce the noise, to control the noise, and also try to make it easy for you to troubleshoot this big network by logically separating it, right? And then domain and then subgroup of the switch ports in an Ethernet LAN. Okay, moving right along. So VLANs can spread across multiple switches. So you can, first we said you might have like one switch, like what we have here in this network, right? Like on this network. So you have here a switch, one switch. So we're saying now by default, all of these devices, they fall under VLAN 1. So once you plug in a device, we'll be able to communicate with these other devices if they are all in the same subnet. So they will all be able to receive messages. So they are in the same VLAN. They're in the same VLAN, and then they are in the same broadcast domain. But now, if we break down this interface or this port now into, make it a VLAN 10, let's do this. Let's say this one becomes a VLAN 10. Let's say VLAN 10. And then make this one a VLAN 20, and then make this one a VLAN 10, and then a VLAN 20, VLAN 20 there. So as you can see now, that means if we have logically separated, let's say we have configured VLAN in this switch, inside the switch, right? We have managed to configure the VLAN. Then that means if this laptop 1 broadcasts a message, only computers that are on VLAN 20 are going to receive that message. So we have created like another broadcast domain inside this main LAN local area network. So we've grouped our devices, subgrouped our devices so that to limit the noise. Let's say, for example, we have like 500 computers. All of them are connected to one switch. Let's say they are all part of one network, right? Those computers. So if there are no VLANs, that means all the devices in this same subnet, they are going to receive that broadcast noise, right? That message, meaning that it will start to slow down your network because of the noise, because of the broadcast messages that are being sent out, right? Okay, where's my slide now? Let me pull up my slide. Okay, so we're saying subnet or broadcast domain. This means that frames broadcast onto the network will be switched only between the ports within the same VLAN. So this is what I mean, right? So if you can see down here, this port is on VLAN 20. This interface is on VLAN 20. And then this one is also on VLAN 20, meaning that the broadcast domain will be only transferred or will be only shared with the VLANs or interfaces or ports that are part of the VLAN 20 only. So now I've grouped my devices, right? Trying to control that broadcast noise. Okay, so let's see another slide that I have. Let's say there. So VLAN increase the number of broadcast domains while decreasing their size, right? So what does that mean? So we're saying, like, let's say you have 500 devices, all of them are in the same subnet. So now if one device sends a broadcast message, all of them, 500 devices in that domain, in that broadcast domain, they're going to receive that message, and then it will start slowing down your network because devices will keep on broadcasting a message for certain reasons, right? Maybe they're trying to find the MAC address of another device, or they don't know the MAC address of another device, so they're trying to pick up or things like that. So that broadcast noise will start to slow down your entire network. So if you break it down, right? So VLANs increase the number of broadcast domains, right, while decreasing their size. So 500 devices, and then we create like subdomains, maybe sub broadcast domains by maybe, let's say we say VLAN 1 or VLAN 10 becomes the IT department, VLAN 20 maybe is for HR department, and then another VLAN. So you are kind of like creating many broadcast domain while decreasing their size. So you kind of having more control of your network. VLAN also reduces the security risk by reducing the number of hosts that receive copies of frames that the switches flood, right? So we know that switches will flood a copy of frame. So it will flood that copy of frame to a specific VLAN, right? So that broadcast will be contained in that one VLAN. Let's say if your device is on VLAN 10, that VLAN, all devices on VLAN 10 will be the ones that receive that message on VLAN 10. So you can keep host that hold sensitive data on a separate VLAN to improve security. So we can also use VLANs for improving our security in our network, right? So those are the reasons why we use the VLAN. These are the reasons why you configure VLAN in our network, right? So you can create more flexible network designs that groups users by department instead of by physical location. So what does that mean, right? Like we have different departments. Let's say you put an IT department on their own VLAN, you put the HR department on their own VLAN. So meaning that the broadcast domain, so a broadcast message is a message that is going to be received by all devices that are connected to the same subnet, right? So now we're saying, even though these devices are on the same subnet, the same LAN, so what we need to do is we want to logically separate them so that the broadcast will be contained in this own specific VLAN, right? And then the following topology, okay, I don't have that topology. So a network without VLANs, okay. So VLAN, without VLANs, a broadcast sent from a host A would reach all devices on the network. That's what I was saying, right? You have 500 devices, and then one device broadcast sent out a broadcast message. All the 500 devices in your network, they will receive that message. Okay, each device will receive and process broadcast frames, increasing the CPU overhead on each device and reducing the overall security of the network. Also, again, it will start slowing down your devices, right? Because of the CPU overhead, right? So, and then also security reasons, we need to configure the VLAN so that we can separate the devices that carry sensitive information and then put them in their own VLAN. So that when the switches are sending out the frame, only these sensitive devices or critical devices will be the ones receiving that message. So we are not, the switches is not broadcasting the frames to the wrong devices, right? So that's the main reason why we have that. All right, VLAN now, by placing interfaces on both switches into a separate VLAN, a broadcast from host A would reach only devices inside the same VLAN, since each VLAN is a separate broadcast domain. Hosts in other VLANs will not even be aware that the communication took place. This is shown in the picture. Okay, let me just show you in my picture. Let me show what I have. So let's say now, let me take out the VLANs. Let's say there are no VLANs, right? Let's say we don't have VLANs on this network. So what happens is, if if computer A wants to broadcast a message, right? Let's say maybe this server wants to communicate with PC 0, right? Or let's start with the PC here, 0 wants to communicate with the server. Because the server now doesn't know the MAC address, because this is a layer 2 communication, right? So because this PC doesn't know the MAC address of this device, of this server, what it does is maybe they only know the IP addresses, right? And then it will send a message, a packet, a broadcast package to the switch. The switch receives that, and the switch checks on the MAC address on the MAC table of the switch. It tries to see, okay, do I have the MAC address of this specific device? If it doesn't have the MAC address of that, then it will broadcast the message to all of these devices. So let me quickly show you what I'm talking about. Let me assign these devices an IP address. Desktop. So just quickly do that. 192.168.10.1. So you can see they are all on the same subnet. I don't need a default gateway. Let me put them all on the same subnet. 192.168.10.2. 192.168.10.3. Let's say 192.168.10.4, right? So you can see they are all in the same subnet because of the subnet mask, right? And the IP addresses. So now I want to show you in a simulation, right? So now if this computer now wants to communicate, send a message to the server, communicate with the server, because this server now, the broadcast message will go to the switch, and the switch will say, okay, I don't have the MAC address of this server in my MAC table, right? So I have to broadcast that message to all the devices. So let's go through that process. So this is the VLAN. So the VLAN, if by default all of these devices, they are on the same what? They are on the same broadcast domain, meaning that if this device broadcasts a message, all these devices are going to receive that message. But if you've configured a VLAN, we create like, we resize our broadcast domain, right? We have like smaller broadcast domains, meaning that if we have VLAN 20, all the messages that are broadcasted on VLAN 20 will remain in VLAN 20. All the broadcast messages that are broadcasted in VLAN 10 will remain in that VLAN, right? So let me quickly show you what I mean by that. I want to ping the server 192.168.10.1, right? So as I say enter, you will see the packet leaving that computer. Let me say play. You can see the packet goes to the switch. The switch now will distribute the packet because they broadcast. So it broadcasts, you see the switch broadcasts to all of the devices. And then it's a broadcast message. So the one that is a 192. You see, this one responds now. The server responds. Here's the message. Here's what I'm talking about on the side here. Okay, let me stop that. Let me quickly show you that. So you can see here, the first one is an ARP, right? Address Resolution Protocol. ICMP is a ping protocol. We sent out a request, right? And then ARP PC 0. The message went to the switch 0. And then switch started to broadcast that message until the server responded. Let me see. So this is information that travels on this side, right? So let me just quickly close this. Let me go back to real time. So that's the information. That's what happens inside this. So the message will move from the PC, PC 0, go straight to the switch. The switch takes that message and then broadcast to all of the devices that are connected, right? And then, but only the device that the message is addressed to is going to respond. Let me see if we responded. So reply from 192.168.10.1. Who is .10.1? So .10.1 is the switch. Is the server. So the server responded. Okay. So that's what's happening there. Let me quickly also show you something before. I wanted to make this video short. So that's what happens between on a layer 2, right? So if we control the VLAN, so on part 2 of this video, I'm going to show you how to configure VLANs. But now I just wanted to go through the process or the concept of VLANs. What are the VLANs? When are you going to configure the VLANs? How are you going to configure the VLANs? What's the main use of VLANs in our network? what's the main reason for us to configure VLAN in our own network, right? So I just want to quickly show you. Let me see if I have ENSP. ENSP. This is the network simulation tool for Huawei devices. For Huawei, it was built by Huawei, right? Okay, let me quickly plug in. Let me say no. I want a new area, new topology. So let's say I add this device there, and then I add another, not a router. I'm interested in this only. So, and then say the network consists of two devices and a medium that connects the two, right? So this is a network. I want to build a small network, and then I want to show you a broadcast message, right? And then let me switch on these devices. Okay, so assign them an IP address. Okay, so hostname, hostname, let me give it A, right? And then IP address 192.168.10. Let me give it a 1. 255.255.255.0. Must be a .0. I just want to show you a broadcast message on the layer 2. So apply that, close, host B. Let me say, so you see we have static and TCP 192.168.10 to 255.255.0. I say apply and then close that. Okay, so now I want to use a Wireshark. Wireshark is a tool that you use to read packets, right? So let me just quickly show you that. If you want to capture data that is traveling on the line, we can use the Wireshark. So I want to capture data using Wireshark. Start the capture. So what exactly do you want to capture? Let me click on that and then ping. I want to capture that ping packet 192.168.10.2, the ping packet. As you can see, my Wireshark tool is ready for me. So here's what I was. So the first message you can see is say Huawei destination. So this is the Wireshark captured the data, the information on the background, how computers communicate. So these are the packets that are sent out when the computers communicate. This is the message or protocols that are used when the computers are communicating. So they use the ARP protocol to resolve, to just get the MAC addresses of the devices. So that message is a broadcast message, meaning all the devices that are in that broadcast domain will receive that message. And then says who is 192.168.10.2 tell. So we sent a ping message to this computer 10.2. So that was computer 1 asking 192.168.10 was asking who is this IP address. So they know the layer 3, they know the IP addresses, right? But they don't know the MAC addresses. So this one will respond now. This is a response 192.168.10.2 is 8. You see, responding with his MAC address. So that's what happens on the layer 2. But the most important part I was looking for is that this was a broadcast message. So all of the devices in that broadcast domain were going to hear this message that this computer 192.168.10 is looking for 192.168.10.2. So only .2 is going to respond because he is a 192.168.10.2. So he responds with his own MAC address. Then he receives that. So it was a broadcast message. So other devices, if they receive a broadcast message that is not directed to them, they will discard that message. They ignore the message, right? Only the device that is directed to will respond with the will respond with the packet saying, okay, here's my MAC address, stuff like that. So that was the VLAN, and the broadcast messages, how they happen behind the scenes, right? What protocols are used for ping all that information, right? So we were just focusing on the VLAN. So now on our second video, what I want to do is I just want to show you how to configure a VLAN. So if you like my videos, you can comment, you can subscribe. So see you on my next video. I will show you how to configure the VLANs on the next video. Right. So these videos you can use them for your CCNA, you can use them for HCNA, right? So if you want to do routing and switching for HCNA, you can use these videos just to go through how VLAN work, and then why will you configure VLANs, where you're going to configure VLANs, and then how to configure those VLANs.